Alright folks, you made it. Last video, we'll make this relatively short, and it's the way we've concluded most every discussion about our different sensors and the idea of how we choose the best instrument for every given situation. And so here again, you're going to see a number of pretty common themes. What do we have to weigh when we're trying to choose an instrument? How much does it cost? What type of accuracy do we need? Are we able to provide regular maintenance, or is that something we desire to avoid? Are we willing to, for instance, pay for that response time? And what is the response time that is actually needed? For many things, the hair hygrometer just isn't going to be enough. And then the one thing that is a little more unique when it comes to hygrometry is the need for most of these instruments to have some type of power consumption to be able to take readings. And so it is something that is not a high-powered instrument by any stretch, but at the same point, when it comes to measuring atmospheric variables, this is about as high as it gets. And so when we talk about different ones, we can talk first about the psychrometer. Just go ahead and put it up for simplicity so you can at least get some of this down while I'm chatting, and then by all means, feel free to pause the screen. Psychrometers, they can cost about $7 a piece if you want to have a couple of cheap thermometers with a rubber band. Obviously, a lot of what we talked about on the previous slide will not hold there, but even then, the one that Jacob continues to hold away from me is a relatively quality one for about $200. Believe it or not, psychrometers can be automated, understanding what is needed with ventilation, at least that 3 meter per second airflow. The idea that it is not a cheap way to be able to measure water vapor, and as such, there are usually better ways if you're willing to pay the price for an automated psychrometer. They're very useful in the sense that you can take a psychrometer out to a weather tower, for instance, and really get a good feel for whether or not the dew point sensor or other instrumentation is working properly. It is going to be an accurate way of doing things, especially if you're willing to put in a little bit of time. And it is also one of those things that we do understand the sources of error, and though they are many, most of them are not particularly complex nor difficult to overcome. Sorption sensors, we can find a number of sorption sensors that are relatively cheap. And although I didn't go into great detail about it, sorption sensors are going to be quite common in a lot of industrial methods. The idea that we want to make sure that atmospheric, or shall I say local relative humidity values are within a given range, and as such we can kind of throw some sorption sensors into a number of otherwise pretty complicated setups to be able to tell a little bit about atmospheric moisture. Small size, low cost, moderate accuracy, so these are not going to be the way that you get your best measurements of moisture. And generally speaking, we can create sorption sensors with low power consumption. I mean, as I brought up earlier, we could make a block of wood be our sorption sensor, although you probably would not like the response time. Drift can be a problem. These are, as you know by this point, my term is that everything's not going to be roses. And so drift can be a problem with these, so regular maintenance is needed if we require a high level of accuracy with a sorption sensor. Chilled mirror. Chilled mirror is what you're going to find on ASOS systems to measure dew point. Chilled mirror are relatively high cost systems. They require notable power. This is why most of your ASOS systems have some type of solar generation to be able to power the ASOS. Not that this is the only instrument that requires power, but it is something that it's not inconsequential. Slow response time, high maintenance, and therefore, if I hadn't already put up all the bullets, you'd probably wonder why would you bother to go with a chilled mirror, because it was a pretty complicated block diagram, or wasn't a block diagram, schematic that I showed earlier. The reason is they're pretty darn accurate. And so it's not to where in most atmospheric setups we have rapidly changing dew points. Yes, I get it. We have dry lines, we have frontal boundaries. But in the vast majority of situations, we don't have dew points dropping degrees per minute. And so even with the slow response, the accuracy becomes very nice with this chilled mirror setup. And it can also work through a number of different atmospheric setups, the chilly winter days as well as the hot and muggy summer days. So the wide operating range becomes very, very useful. And so exposure becomes an issue as well when we deal with our hygrometers. We want to oftentimes locate them near the temperature sensor, especially if we have something that is measuring relative humidity or dew point, because of the requirement or at least relationship between atmospheric temperature. Most of the time they're going to be enclosed but not have any type of forced aspiration. We want to avoid any type of dust contamination. For instance, with the chilled mirror setup, dust is definitely a big issue. If you start to get dust on that mirror, it's going to start to change the reflected versus scattered portion of the LED light. And so any type of dust contamination can be very difficult with some of these sensors. Not surprisingly, we also want to avoid direct solar radiation. That's probably a given at this point, but it's one of those, especially if we have a temperature-based setup, we want to have the dew point sensor or relative humidity sensor also be located in a way that the solar radiation is not a big player. And this is kind of the end. We don't want any type of sprinkler system that's affecting it. And so even though it might be silly to think having a sprinkler going onto our humidity sensor, in reality, we still don't want even a nearby sprinkler system where we would be creating a localized high moisture environment that would not be indicative. It wouldn't be representative of what was going on across the area. You've made it. Congratulations, and hopefully you get a chance to watch these before the final exam next week. Take care, and hopefully you've enjoyed these lectures.